So, you're here, which probably means you've already gotten pretty good at the basics. You know how to get an AI to think step by step. But let's be honest, coaxing isn't engineering. In this deep dive, we're going to move way beyond just prompting as some kind of art form and really step into the world of prompt engineering as an architectural discipline. We're going to figure out how to stop asking for reasoning and start building it with absolute precision and control.
All right, so here's our game plan. We'll kick things off by talking about that big shift from art to engineering. Then we'll formally define what a reasoning steps component actually is and, crucially, how it's different from chain of thought. After that, we're getting practical. We'll look at some real architectural processes. Then we'll hit a really critical insight, something I'm calling the Great Divide, before we wrap up by looking at what's next for AI reasoning.
You know, in the early days, prompt engineering really did feel like an intuitive art. We were all just trying to find the magic words, right? The secret incantations to get the model to do what we wanted. But the field has grown up, fast. We are now in an era of real, rigorous engineering, where we don't just ask for an answer. We design, we prescribe, and we can actually verify the exact cognitive workflow the model has to follow to get there. We've all used it. I mean, that little phrase, "let's think step by step," was a total game changer. It unlocked abilities in these models we didn't even know were there. But is that really engineering? Or is it more like just knocking on a door and hoping the right person answers? You see, that phrase is just a general nudge. True engineering, well, that requires a blueprint, not just a friendly suggestion. It demands a level of precision that think step by step just can't deliver. So to build that blueprint, we need to move past these little sayings and into a more precise technical term, the reasoning steps component. Now, this isn't just another technique, it's a formal, structural element inside your prompt that has a very, very specific job. Think of it as the actual architectural plan for the model's entire thought process. Okay, so here's the formal definition. Let's break it down. When we say structured logical units, we mean these are not vague suggestions. They're distinct, concrete commands. Sequential cognitive operations means they define a specific, unchangeable order of thinking. And maybe the most important part here, verified. This means the model has to show its work in a way that allows us, the engineers, to check every single step for logical consistency. These 5 characteristics are really what make reasoning steps so different from plain old instructions. First, they are process-oriented. They command how to think, not just what to do. They are sequential. Step 2 absolutely has to follow step 1. They are intermediate. This is the hidden thinking, the stuff that happens between the question and the answer, now made visible. They are verifiable, and this is huge because it makes the final output auditable and trustworthy. And finally, they are decomposed. They turn what might seem like an impossible leap of logic into a series of small, simple, reliable hops.
So where does this component actually live inside a prompt? Well, in any modern, well-structured prompt, there's a clear anatomy. You start by setting the role or persona. Then you give the high-level instructions or directives. And then, right in the middle, you insert the reasoning steps. It's the cognitive engine that runs before the model even thinks about the final output format. And let me tell you, that separation is absolutely fundamental to building reliable prompts.
And this brings us to probably the most common point of confusion out there. So many people use reasoning steps and chain of thought as if they mean the same thing. And that is a huge mistake because they are fundamentally different concepts and they operate at totally different levels of control.
So first, let's just make sure we're clear on the difference between instructions and reasoning steps. An instruction is task-oriented. Write a summary of this article. A reasoning step is process-oriented. First, identify the main claim in the article. Second, extract 3 key pieces of supporting evidence. The GPS analogy here is perfect. The instruction is your final destination. The reasoning steps, those are the mandatory turn-by-turn directions that you must follow to get there. One defines the goal, the other prescribes the exact path.
Okay, and now for the main event. Chain of thought versus the reasoning steps component. This is the core idea of this whole explainer. Chain of thought elicits reasoning. It's a general technique, a nudge, basically asking the model, hey, could you please show me how you're thinking? The reasoning steps component, on the other hand, prescribes a specific reasoning process. It is not a request, it's a command. It provides a detailed cognitive algorithm that the model is mandated to execute step by step. One is a general idea,
The other is a formal structural part of the prompt that puts that idea into action.
And if you remember absolutely nothing else, please remember this analogy. Chain of thought is like a teacher just saying, show your work. The student can do that however they want, really, as long as you can see the process. But the reasoning steps component is that same teacher handing out a detailed, structured worksheet with predefined sections. Part 1, list your variables. Part 2, state the formula. Part 3, solve for x. See the difference? It's not just an encouragement to be transparent, it's a structured mandate for a very specific cognitive algorithm. Okay, that's enough theory. Let's get our hands dirty. How do we actually go about building these cognitive workflows? This section is all about moving from just understanding the concept to actually applying it. We're going to look at how we got here, and then we're going to dive into some specific, powerful templates that you can adapt and start using right away. To be a good architect, you kind of have to know the history of your materials. It all really kicked off in 2022 with the chain of thought we all know, and it was a massive breakthrough, but it had a big flaw. It was brittle. One little mistake early on could ruin the whole thing. So in early 2023, researchers came up with Tree of Thoughts. Instead of one path, TOT explores multiple branching paths at the same time, evaluates them, and picks the best one. Way more robust. But even then, those paths were separate. A few months later, Graph of Thoughts let those paths actually merge and share info, kind of like a team of experts collaborating. And finally, late in 23, we got frameworks like React, which created this agentic loop. The model could reason, then act, by using a tool like a calculator, and then observe the result to figure out its next step. This whole journey, from a simple line to a complex agent, shows this relentless drive for more powerful and human-like reasoning. So let's see how this works with a practical template for generating code. Instead of just saying, write me a Python script, you prescribe the process of a senior developer. First, you force it to make a plan in plain English, forcing high-level thinking. Second, you make it write pseudocode, which structures the logic before it gets messy with syntax. Third, it can implement based on that solid foundation. And then, crucially, step 4, you force it to anticipate errors. This one step right here transforms the output from just a script that works sometimes to robust production-ready code that actually handles edge cases. That's the pro move. And this isn't just for techie stuff. The exact same principle works just as well in a completely different world, like business strategy. This isn't just asking, what should we do? It's a full-blown analytical framework. You make the model, define the problem, analyze the competition, evaluate multiple options with something like a SWOT analysis, and, here's the expert move again, assess the second-order effects. What happens after what happens? The model can't just give you a simple answer. It's forced to give you a deeply reasoned, structured, and defensible strategic plan. All right, now we have arrived at the most critical, expert-level insight of this entire explainer. What I'm about to show you represents a massive shift in the field. The idea that you can have just one prompting strategy that works for all models, well, that idea is now dangerously obsolete. There's a great divide, and knowing which side of it a model is on is the difference between amazing results and total failure. So, does one size fit all? Can you use the same prompt strategy for every model? The answer is an emphatic, unequivocal no. In fact, what works wonders on one class of models can actually cripple the performance of another. This is the great divide. You absolutely have to understand this. Okay, check this out. On the left, we have what we can call non-reasoning models, like GPT-4o. For them, chain of thought is essential. You have to give them that prescriptive step-by-step scaffolding. But on the right, you have the new reasoning models, like the O series that are emerging. For these, you must avoid explicit CoT. Why? Because telling them to think step-by-step is like telling a grandmaster chess player exactly how to move each piece. You're just getting in their way. You're constraining their own superior native reasoning process. For these advanced models, you go minimalist. You treat them like a top-tier consultant, clearly define the goal, give them the context, and then get out of the way and trust them to find the best path. So, we've just established this incredibly powerful tool of prescribing reasoning, but it's not a silver bullet. To be a true architect, you have to understand the limitations of your materials, the trade-offs of your designs. So let's get real about the costs and the future of this whole discipline.
You see, prescribing reasoning isn't free. First off, it dramatically increases your token count. That means higher costs and slower answers. Second, like we talked about, linear chains can be brittle. One tiny error in step 1 can cascade down and give you a very confidently wrong answer. Third, these long reasoning chains can eat up your whole context window, making the model literally forget what it was supposed to do in the first place. And finally, sometimes you need creativity. For those tasks, an overly rigid set of steps can be like a straitjacket, preventing the model from discovering a way more elegant or novel solution.
This all leads to a really profound idea about what it is we're actually doing here. All of these complex techniques, COTI, TOTI, our prescriptive reasoning steps, they're best understood as a form of cognitive scaffolding. They are temporary structures that we build around the model's mind to help it construct something more robust and reliable, especially for models that don't have these capabilities built in from the start.
And that points directly to where this whole field is going. The very existence of those reasoning models we just talked about tells you the whole story. The end game isn't about us creating more and more complex prompts to force a model to reason. No, the future is models that have these complex planning and verification abilities trained in from day one. Our role as engineers is going to evolve, from being micromanagers of thought to being high-level directors of goals for increasingly autonomous AI agents.
So, I'll leave you with this one question. After everything we've gone through today, from formal definitions all the way to the Great Divide, it's pretty clear we've moved beyond just asking simple questions and getting simple answers. The job description has changed. So the next time you sit down to work with an AI, ask yourself this: are you just writing a prompt to get a response, or are you consciously, deliberately architecting cognition?